Hello everybody, this is the Fusion 360 training tutorial on machining the TCOSE-06 model. Now this part is cylindrical, so it's a good turn part, but it also has two drilled holes that need to be done on a mill. So we'll be doing the programming for both. Let's open up our TCOSE-06 model. Go ahead and close the data panel, and it should look something like this. Now you should have revolved this model when you made it. If you did not, you may need to do an extra step. The reason being is the turning follows a profile, and in this software you have to have a sketch that follows a profile if there isn't a hard edge. So we're going to go to the model visibility, and you want to make the sketch you use to revolve the part, you want to make that visible. If you don't have a sketch that's like that, what you can do is go back into design mode and create an intersection curve on the center line, and that will do the same thing. But what you're trying to do is you need these perimeter edges in order to do the turning work. So if you don't have something that resembles that on the screen, stop the video and come back when you have geometry that traces the profile of the part. So I'm going to go ahead and collapse all that. Okay, so we're going to make a turning setup. We need to first switch the turning, and then the menus change here, and it also affects the setup. So let's create a setup. Yours should say 1, but mine may not. And you want to change the operation type from milling to turn or mill turn. Now mill turn is a machine that can do both. So it's should default to a cylindrical piece of material, and it's automatically offsetting all the sides. We want to change our axis orientation known. Now Z is always in the axis of the spindle. So you remember in a lathe, this is held in a chuck and is spinning, and the tool is fixed, and it moves in the x-axis. This looks pretty good. If you have the z-axis in line with the cylinder, then that's correct. If it isn't, you're going to need to go to this selection here, and you're going to need to select the z-axis, rotary axis, so you can just pick on one of the cylinders. And that should point Z in the same axis as the spindle. Now our x-axis, it looks like it's pointing the wrong direction, so we're going to flip that. Now it does depend on the orientation of your lathe. We're programming for a slant bed lathe. The tools are actually going to be upside down in orientation to the operator. So this would be the orientation for a slant bed lathe. Okay, so we're going to set our Z safe. So this is the equivalent of our rapid planes. So it's defaulting to an offset of the front of the stock of 0.96 something or other. Let's just round that off to 0.2. And we need to select the model. And our model back is going to be about 400 thousandths from the back of the model. And we're going to go to our stock, and we're going to use relative size cylinder. And we're going to do a radial offset, which will give us a common diameter size that we're able to purchase. So 3, and then because we're going to try to hit 3/8, which is 0.375. And what we can do is round it to the nearest 5 thousandths, and it will round that decimal point off. Now the front side we want to leave a little bit of stock, so let's say 0.03 on the front. And on the back side we need to hold on to something. Now we have 400 thousandths in front of the chuck, so if we're going to have the chuck hold on to about 1/2 inch, we need to put in 0.6 there. So when we go to cut stock, we need stock that's an inch, 0.3735 by 3/8 in diameter to make this part. Now we're going to go to post process, and we're going to call this 0601, and you could say operation 1 lathe, and work coordinate system 1. Okay, we should be done with our first setup, and we should get a setup here. Now we're going to go ahead and continue to do the programming on this part, and then when we go to do the mill setup, we'll make the setup for that. Okay, the first operation we want to do is machine off the face of this cylinder so that we have registered our known length. So we added, I believe, 30 thousandths that have to be removed from the front of that part. To do so, we're going to use a turning face operation. Okay, and we're going to select a tool, and you should be using the rocket tool library from Titan to machine these parts. And we're going to use tool number 2. Now you can do facing with a grooving tool, but this is a general purpose tool that we're going to do a bunch of the outside work with. So we're just going to select tool number 2 and OK. And again, the tool should be inverted because in a slant bed lathe it is. And it's going to machine just the face of the part, whatever was pointing towards Z. Okay, we're going to take all the default settings here, but I'm going to spend a second to explain what they are. So on a lathe, different than on a mill, you program in a constant surface footage, and that would come from the tool manufacturer. And then you put a maximum RPM speed. So it's going to try to achieve that surface footage and keep it consistent. So as the cutter gets closer to the center, it's going to spin faster and faster. But it won't exceed the RPM you put there for safety. Now I'm going to leave it at 500. I'm pretty sure we could go higher than 500 on our lathe, but we'll just leave that be. Now the cutting feed per revolution, that is the chip load. So when you look at the chip load in the catalog for the insert, that's the number you'd put in there. And that's because it's in inches per revolution. So when you were doing your calculations for mills, everyone's asking, why are there different terms for chip load? Chip load is specific to milling, and the inches per revolution is more specific to lathe industry. So for whatever reason, they have different vernacular for the same number. Now, unlike a milling cutter, your lathe cutters only have one tooth. So you're just going to put the straight raw value in there. We're going to go to face. So the face is the front of the model. And we can just leave that alone. Now we're going to go to clearance. Now the clearance plane is instead of planes are cylinders for a turned part. So we have all rapid movements between the orange and this brown, and retract is going to be rapid, but feeds are going to be feeding in from the brown cylinder. And then we have our actually cutting feed from the cyan to dark blue. Now we're just machining this face here. So what we can do is we can leave everything here at default, except for we're going to cut a distance below the inner radius. And what that'll do is have the cutter go past center just to make sure you have a nice clean blend on this center, because sometimes if the tool's not set quite correctly, you'll have a little miniature cone or dimple on the end there. So we're going to go 0.02 deeper than the center of the part. Now we're going to move on to the next tab, which is passes. We'll leave these all at default. We're not going to leave any stock. I was having issues with the cutter comp, so we're going to leave that at default. And we're going to leave all these others at default here. What this lead in is it'll approach the work about 0.08 before the stock theoretically starts and come in at a 45-degree angle, which helps the cutter engage initially. And we're going to use lead in, lead out, and we'll hit OK. So our tool path has our 45-degree lead in. It's cutting it where the stock starts, and then it should be going a little bit past. That was probably too much for a small part like this, but that'll ensure that we've cleaned up. Now on that side of the part, it's really going to be rubbing on the non-cutting edge of the insert. Alright, so now we will move on to the next routine, which will be to rough this outside profile here. Okay, so we're going to use this second command here. It's called turning profile roughing. Select on that, and we're going to continue using the same tool. We will leave all of these at default, and we're going to move on to geometry. So on the geometry tab, we need to select model, and then we need to pick the sketch that we revolved our part on. Now in the geometry, we've already machined off the face, and then when we come back and part off the part, we want clearance for the parting tool. The parting tool is 118 thousandths wide, so we're going to overshoot by about 1/8 inch to give it a little bit of extra clearance. On this side, we'll probably overshoot just a little bit, just to make sure that if there's any registration difference in the tools, that we don't start the cut right inside the work. So on our front mode, we're going to do what's called a tangential extension. So we're going to put a 0.01, which is 10 thousandths, and that's going to extend our initial cut by 10 thousandths off the model front. Now on the back side, we're going to put in a tangential extension of 0.125. So it's tangent to the cut, and it's going to extend to neck this down more so that when we come in with our grooving tool, we're not cutting as much material. Now we're going to move on to radii. So on this, we're going to leave the first two at default, but we're going to set our inner radius, instead of it being this center here. We don't want to go to that center. We're going to go instead from stock ID to selection, and then we select the smallest diameter on the part. So outside of our cut, it's going to go from the cyan, and it's not going to go any smaller than the blue. Okay, now we're going to go to passes. We're going to go horizontal passes from front to back. Allow radial grooving. We're going to skip can cycles. Tolerance 4/10 is fine. Depth of cut, let's put 0.03 for 30 thousandths. Sharp corners. We're going to leave a finishing allowance for our finishing tool, and so that'll be 4 thousandths. It's fine at default. we actually don't need the Z finish allowance, but it doesn't hurt. You can just leave it. Okay, now let's go to linking. We can pretty much leave these all at default. On our clearances, match what I have here on the screen if you don't see the same thing. And we're going to hit OK. Okay, and you should have a series of cuts that look somewhat like this. Now notice we're leaving extra material here, and that's because of the nature of the angle on this tool. And it leaves a pretty good size radius here. We're going to come back with another tool and remove that material after we're done with this tool. And you notice that we've cut beyond, and that's our tangential extension. We went an extra 1/8 inch out past here, past near the chuck. All right, now we're going to do the next command over. It's the turning profile finish. So it's going to take this profile down to finish size. We're going to use the same tool, all the same settings. We're going to go to geometry. We're going to select model and select the same curve that we had. And then we can we want to have the same tangential extensions we had on the other. So 0.01, and we want 0.125 on the back side. We're going to move over to radii, and we're going to do the same thing we did before. Instead of stock ID, we're going to switch to selection, and then we're going to select the smallest diameter on the part. We're going to go to passes now, and we're going to leave all these at default except for our step over. We're going to set that at 0.004. The reason being is that was the amount of material we left on the roughing. So we're going to take off the same amount of material, 0.004. We're going to go to our linking tab, and we should be able to leave most of these at default. Our lead-in length is fine, but we're going to do a linear at 0 degrees on this angle, and what that will do is come in at the same angle as the cut, since we've already removed the material. And on this case, we don't want to lead out, so we're going to deselect that so that we only have a linear lead in. All right, so we're going to hit OK, and we have our finished profile cut. We lead in 0 degrees, still leaving a fillet, but it's removed to finish size these diameters. Okay, the next step is to remove as much of the square fillets in these corners as we can. So we're going to use the single grooving tool command. Select single grooving, and we're going to select tool number 4 on the rocket library, which is a square grooving tool. Looks like this. And it's called square. The inserts still have a really tiny radius here, but this is a very small part, and I think it's something like a 4/1000 radius. It's really tiny. So that's the sharpest tool we have. You probably can grind a truly sharp tool if you're going to use high-speed steel, but this library doesn't contain one that's absolutely square. All right, so we're going to leave all our settings at default on the feeds and speeds. On our geometry, we're just going to select one side first. So we're going to select this line, and we want offset on that tool to be based off the back of the tool itself. So the cut is on the back of the tool as you would display it. Okay, we're going to go to the next tab, and we're going to leave all of these at default. It's going to cut to the selected contour. Now we'll go to passes. We'll leave these all at default. If you were cutting a lot of material, you'd do more than one pass. And then we're going to go to linking tab and leave all these at default. We'll hit OK. As you can see, we wrap it in, and this would be considered the back side of the tool, and this would be considered the front side of the tool. This is the front side of the part. This is the back side of the part. Okay, so it's now cleaned up that corner and made a super small radius. Now we're going to do the same exact routine. So why don't we go ahead and right click on this routine we just did, and we're going to duplicate. Now on the duplicate, we need to change some things. We're going to hit edit. Everything on the first tab stays the same. The geometry tab gets cleared, and we're going to pick the line on the back of the part. Now, because we're cutting the feature on the other side of the tool, we need to change the orientation to the front of the tool. Alright, and then the rest of these we can leave at default, so we'll hit OK. So this is going to wrap it over, and it's going to feed in such that the front of the tool cuts right where this groove starts. Okay. Alright, we're almost done here. Then we'll simulate. Alright, our last operation is going to be to part the part off. At least last operation on the lathe. We'll go ahead and use tool 4 for it. There are some other grooving tools in the library, but this one should just do fine. Okay, so we're going to select the turn and part command, and you can see in the icon it looks like the part itself is blue and the stock is gray. Select on that command, and it's going to actually automatically default to the back of your model, what you've defined as back on the setup. And we'll leave all these things at default. We're going to go to geometry, and it's the model back, which is the back of the model. And unless we wanted to, for some reason, leave extra stock, we would leave that at default. Now we go to our radiuses. Now we're going to leave all of this at default except for the last one. Now if we had a parts catcher, we would treat this like the front. We would go to stock ID 0 as it is and go a little bit past to make sure it chops it off. Our lathe doesn't have a parts catcher. So what we're going to do is go to stock ID, but we're going to leave an offset of 0.015. And what we'll do is it'll leave a 30-second diameter stem of stainless that we should be able to break the part off manually by hand. Now, the risk we have here is that it becomes so flexible it starts flopping around. If that happens, then we need to change that parameter and make the little spud sprue that connects it a little bit bigger in diameter. We're going to go to passes. We're going to leave all this at default. And then we're going to go to linking tab and leave all that at default. Select OK. And you can see the outline in yellow. That's what's going to be left to hold this part on so that it doesn't fall into the chip bin. There have been cases where I left quite a bit of material and used a saw to cut off the part. Then you got to come back and clean up this face. Alright, so that's it for the lathe programming. Now let's simulate it so you can see what we've done so far. Make sure your stock's enabled. And we'll hit play. Okay, so it's currently facing off the front, and now it's roughing the outside. And it should be coming in now to do a finishing pass with the same tool. And now we come in with the grooving tool to take out the fillets and extra material. going to come back and part our tool. All right, that stem might not work. We might have to increase the diameter on that. But in theory, if you do it right, it should work. We've done that on several parts. All right, we're going to hit close, and now let's do the 1 mil setup we need. Now the mill setup is to cut this 1.5 millimeter diameter hole. Now I would suggest when you get this part, you set it up with a mill and drill one hole, and then have a fixture that can index that hole so that when you drill this one, it's 90 degrees from the other one. And then that same fixture would hold the cylinder horizontal to the table. If you do that and use proper fixturing registration, you can just use one program to make these holes. You just keep flipping the parts accordingly. So that's what we're going to plan for. So let's switch to milling mode. And now we're going to make a milling setup for this part. Now all of the stock is removed from this. The stock is the part itself. So we're going to go to stock, and we're going to change to no additional stock. So we're going to change this from relative size box to from solid. And we'll go ahead and select the model. And now we need to orientate our axis. So let's go to setup. Now my z-axis is already pointing in the correct direction for this hole. If yours is not, you need to use this select z-axis plane and x-axis to reorientate your x-axis. My x and y are already in the place they should be. So first you need to manipulate your x, y, and z axis to look like as shown. And once you've done that, we're going to pick a stock box point, which is going to be this one here. So it'll be on center line on the end of the part. We'll be able to set our tools to the top of the biggest diameter and on center line of whatever our fixture is. And then we'll be able to edge find on the end of the part for the x-axis. All right, we're done with that, so we're going to go to the post-process tab. We're going to put in 0602 is our program number. Program comment is going to be operation 2, and it's going to be on the mill. That way we know what the program's for. Can't run a lathe program on a mill. Okay, and work coordinate system 1. Let's select OK, and we're going to go to drilling. We're going to select the TCOSE library, and we're going to select tool number 11 for the 1.5mm drill bit. And select OK. Okay, I'm going to leave all this at default. We're going to go to geometry, and we're going to select the one hole. We're going to go to heights. We're going to leave all the stuff at default except for we're going to select drill tip through, and we're going to go an extra 0.03 deep, so 30 thousandths, to make sure our drill really clears all the way through the hole. You'll have to account for that in your fixture to make sure you've got space for a hole there. We'll move on to the linking tab, and we're going to do a deep drilling. That's going to give us PEX, and we're going to do PEX of 0.015, that's 15 thousandths, and we'll just leave that at it as it is, and we'll select OK. Alright, so we should have deep drilling, goes all the way through, and that is our only setup for that. Now when we post-process this, because we put notes in, this one will say mill in its description, this one will say lathe, and you'll know which machine to run that on. Okay, so if we were to simulate that guy, not going to be that exciting, but you can go ahead and run that. Now, because we call the stock the model itself, and the model had the hole in it, it looks like it's not really making the feature, but so then you would flip the part 180 degrees and then rotate it 90 and maybe line it up with a pin and rerun the program. Oh, and of course, you are going to have to post-process and make setup sheets and upload those on Canvas. So for this, you should have 2 programs and 2 setup sheets. One for the mill and one for the lathe, which is called turning. All right, I'll catch you on the next one.